about is atomic mass. So atomic mass is important because when we start getting into stoichiometry and moles and how chemical reactions are going to be done, right? The way we're able to account for all of this is through mass, right? Because mass is directly going to be related to how much of each species we have. So when we do chemistry, masses are incredibly important, right? The weight of things is incredibly important. So something interesting about mass is if we look at, the periodic table, and let's say we look at carbon, and the reason we're going to look at carbon is because carbon is the basis of, how we calculate the atomic masses. If you look at the atomic mass on the periodic table, it's 12.01, and we also know carbon is element 6, right? Meaning it has 6 protons. And this is also the atomic number, right? And this is the atomic mass. But the question is, where does this number of 12.01 come from, right? Well, when we start to talk about masses, we know we have isotopes, right? And isotopes are just different elements, right? Or the same, it's an element that has a different mass, right? So for carbon, we have carbon 12, right? So we know we have 6 protons still in carbon 12, but in this case, we have 6 neutrons. And we also have carbon 13, right? So these guys are isotopes of one another. Now, the thing with isotopes is it's not a 50-50 ratio, right? You don't have 50% of one, 50% of another. They just occur in different amounts, right? So in the case of carbon 13, there's actually 1.11% of this found in, if you had a lump sum of carbon, right? Let's say you had a gram of carbon, you would have 1.11% carbon 13. And of that 1 gram of carbon, 98.89% of it would be carbon 12. Okay, so the significance of this is when we go and we say, well, where does this 12.01 come from? If we convert this into a ratio, right, we get, messed up there. You get a 0.9889. And if we times that times an atomic unit of 12, so this is 12 AMUs, right? And the 12 is coming from the atomic mass of carbon 12, right? And we add that, right? We're going to add that to 0.0111, right? That's just, 1.11% being converted into a decimal, right? And we multiply that by 13 AMUs, which is coming from carbon 13, right? So 13 AMU. What this value is actually going to be equal to is going to be 12.01 AMU, or atomic units. So that's actually where the atomic mass comes from. So let's say we have this 1 gram of carbon. Well, we can't just, arbitrarily say most of it is going to be carbon 12, therefore we should just say it's 12. What we actually have to do is take into account the relative percents of both carbon 12 and carbon 13 in that amount so that we can get the most accurate atomic mass of carbon, or the most accurate weight that carbon sample will be.